Okay, now we move on to calculators, and lots of different calculators have different keys. Basically, on your calculator, you will either have the up caret key to raise things to a power, or you will have an X to the Y button, or you will have a Y to the X button. Those seem to be the three main keys. As far as logarithms are concerned, you've got the regular common log button, LOG, and then you have the natural log button, LN. Above your log key, it should have written 10 to the x power, and above the natural log key, it should have e to the x power. And sometimes those are not written on the calculator, but they're really there. You should be able to hit shift or second function to be able to access those if you hit this log or natural log key. Okay, we also have to determine whether your calculator is a forward calculator or a backwards calculator. Now, for raising something to a power, all of our calculators are going to work the same way. You're going to type in this 3.07. You'll hit your raise it to a power key, one of these three on the first row. Type in your 1.42, and out will come your value. And this should be approximately 4.9174. And as a general rule, I'm going to be rounding these to 4 decimal places. Now, when it comes to e to the first power, this is really an e to the first power, some of your calculators are going to work in different ways. Some of you will access the e by going shift or second function with this ln and get your e to the x showing on your screen, and then you will hit the 1 after it to type in e to the first power, and out will come the answer of 2.7183 after we do our rounding. Others of you do not do it that way. You have to type in the power first, 1, and then hit second or shift e to the x, and then get your power out that way. If you can type it in as you see it by typing in the e first, I call that a forward calculator. And if you have to type the power of 1 first and then apply the e to the x to that, I call it a backwards calculator. And both work the same way, well, a little bit differently, but you can get to the same answer is what I'm trying to say. For natural logs, some of you will hit your natural log button, then type in 317. Others of you will type the 317 first and then hit the natural log key. It just depends upon your calculator. The answer here is going to be 5.7589 when you round this to 4 decimal places. And this last one, and you really do need to check this, is going to become 43.8160 when you round that to 4 decimal places. Okay, we now change gears and we want to evaluate these logarithmic expressions, and you can't do these directly on your calculator, and the idea here is we want to be able to do this in our head. Now, we wish there was an equals x off to the side, because then we could write 2 to the x equals 16 using that visual pattern. But unfortunately, we don't have that equals there that equals x there. And so instead we're going to say 2 to the to the what makes 16. And then we can answer 2 to the 4th makes 16, and that logarithmic expression is equal to 4. Likewise, on this next problem, we say 3 to the makes 1/9. Well, 3 to the -2nd makes 1/9. That negative makes this a fraction, and the 2 makes that 3 squared to a 9. And so that one works. Let's do the next one. A little bit different here. We have to understand that whenever you have a natural log, there's an understood base of e written in there. Common logs written log have a base of 10. Natural logs have a base of e. So now we're going to be saying e to the makes 1 over e to the 8th. And the answer is -8. And this kind of leads us to solving some logarithmic equations. Here we're going to take this base x, raise it to the 4th power to get 16. X to the 4th there is equal to 16. Now in your head you're probably saying 2, 2, 2. The answer is 2. But technically this is a 4th degree equation and there should be 4 answers. If we were to bring the 16 to the left and write x to the 4th minus 16 is equal to 0, this will factor into x squared plus 4 times x squared minus 4. And then we would have answers of 2i, negative 2i, 2, and negative 2. But it turns out that you cannot have a negative base because we're solving for the base there, or you can't have an imaginary base. So you were right in guessing, 2, 2, 2 is the answer, but we had to go through and verify why that was the only answer. In this next example, rather than having a missing base, we have a missing argument, but we're still going to write this pattern here. 3 to the 5th power is equal to x, and we're going to simplify it. 3 to the 5th power is equal to 243. On this third pattern, we're missing the value on the other side. 5 to the something equals 25. 5 to the x equals 25. Luckily, this is a clean problem, and we can just see by inspection that the solution is equal to 2.